All right. Welcome, fellow evolutionary classmates, to week 3's part 1 screencast. So for this week, I had question 1, which is summarize the basic principles of used in relative dating. And from my reading and my studying, I basically found, we'll say, 1 overlying principle and then 3 principles. So the first thing we have to consider is uniformitarianism, which is the claim that all geologic processes that we can observe now are the exact same as what happened in the past. This allows us to look at what we see happening today in the Earth and basically make assumptions about the fact that if we see those geologic events through the strata and through our geological discoveries, then that probably is what happened then as well. Other than that, that's pretty much the overlying principle. After that, we break into 3 others. And to do this, I want to show a picture of strata. And let me get my screen sharing going on here. So this is just a picture taken straight off of Wikipedia. Give me a minute to find it. Apparently it is not pulled up. So, okay. So here we go. So here's a picture of strata pulled straight off Wikipedia. As we can see, there is the sedimentary rock layers, which are E, C, A, possibly F as well. Unless A is that line. I can't tell if A is the line or the stratum. Then you have D and B, which are different. So the first overlying principle is the law of superposition, and this applies only to sedimentary rocks. So for this example, we can look at C and E. And basically what the law of superposition is that any layer is older than the layers on top of it. So as you can see, layer C would obviously be older than layer E because it falls underneath it. For layer C to fall first, it had to be older. The second principle we have is the law of original horizontality, which is basically a complicated way of saying when strata was originally put down, sedimentary strata was originally put down, it lays down horizontally. I like this picture because, as you can see, the strata farther back may not have stayed horizontal due to geological events. But C and E, again, are semi-perfect examples of this. You can see that C and E were originally horizontal. Now F has moved a little bit of C, but they originally started horizontal, and they will stay that way until a geological event moves them, basically. And then, of course, the last principle for question 1 is the principle of cross-cutting relationships. Now, this applies to igneous rocks, basically rocks that come from volcanic events. D is definitely an igneous rock. B probably is as well, but I'm not so sure, so don't take my word on that. And basically what this is this principle states that the igneous rock is younger than any strata that it lays on top of. So as you can see, D, which was some kind of thermal vent or pocket, cross-cuts through especially C and a number of the older strata. So it would be younger than C because it cross-cuts above it. Anyway, that pretty much sums up the first question in part 1. I hope you enjoy this podcast, and I look forward to seeing you in part 2.